that are subtractions. I first notice this, and then I say, stop, be very, very, very careful, because I know the subtraction changes everything that's behind it. So that's where I'm going to make my error, if I make it at all. What's the LCD in this case?
X plus 4.
X plus 4 minus 4, right? So it's just a difference of squares. This guy is the LCD, because he's x plus 4x minus 4. So I'm going to have 8x over the LCD, subtract 5 times x minus 4 over the LCD. So that over the LCD, I'm going to have 8x minus 5x plus 20. And I just made a big tactical error. What tactical error did I make? What did I do that I could really screw myself up? Yeah.
Negatives and positives?
Yeah. And see, what I should have done, because I did it here, I moved from this step to this step here. And I can tell you that's not a good idea. That's why I make notes to myself. What I should have done is this step right here. And on an exam, I would do that so fast. Why? Because whenever I multiplied that through mentally, I could drop a sign. So easy. I should have done this and then multiplied it through. That's a safeguard to keep you from making an error. On exams, it counts big. So that's where you don't want to get yourself into a position where you make an error that you shouldn't have. So 8x minus 5x is 3x plus 20 over the LCD. And we're done because that doesn't factor. And we know the LCD is x minus 4, x plus 4.
Why did you say you made a tactical error if you got the right answer?
Well, because I didn't at this. The tactical error was the chances of my making an error at this point, doing the mental transition from here to here, are greater. So on an exam or someplace that's going to count, I'm going to go through and I'm going to put that extra step in, because that basically takes care of the chances of my making an error. I might be okay going from here to here on homework, and if I make the error, I can go back and correct it, because you check the back of the book and you know your answer is wrong. But in an exam situation, you don't have that. I mean, I kind of learned that the hard way in physics, because I had a physics instructor that marked you wrong from where you made your mistake. And it was a 25-point problem. And I made my mistake step 1. I have about 5 steps. Out of 25 points, I got 5. Even though everything else was letter perfect and I knew exactly what I was doing, but I carried that error forward. So I kind of learned that that was not the thing to do. You just be very careful, that's all. You don't want unforced errors. Now here's the nice thing. He's all by himself. Let's see if there's an x minus 2 in this denominator. Well, this looks like it's an x plus 5, x minus 2. So he's the LCD. Because he's an x minus 2, what am I missing? An x plus 5. Now, he's also the LCD. My middle ground problem would be x squared minus 39 minus 10 times x plus 5 over the LCD. Now I know the minus 10 multiplies through minus 10x minus 50 all over the LCD. which is x squared minus 10x minus, oh, I like that, 89, all over the LCD, which is x plus 5, x minus 2. And I know I'm not going to be able to cancel anything out. Why? Does 5 divide 89? No. So there's not going to be an x plus 5 no matter what. Does 2 divide 89? No. So there's not going to be an x minus 2 no matter what. Do I even care what the numerator does? No.